Hello, in this video, you will learn how to operate TecQuipment TD1002 module for thermal conductivity experiments. When you first come to the instrument before your experiment, probably the instrument will look like this. Everything should be off. This cylinder is the main part of the instrument, including the solid sample piece. And this is the control panel. This cylinder is composed of three parts: front piece, end piece, and a mid-section metal sample piece which you can swap. The front piece and end piece contain brass pieces inside these white housings. 7 thermocouples embedded in the cylinder, and they are connected to the control panel. They are numbered 1, 2, 3, 4, 5, 6, 7, from left to right, and from the front to the end. The front piece has 2 thermocouples, the mid-sample piece has 3, and the end piece has 2. Piece will be heated by the electrical heater, and the end piece will be cooled by the recirculating chiller. So heat will transfer from the front to the end. I will show you how to swap this middle sample piece. If you swap samples between trials, make sure you turn off the heater and turn off the chiller, and make sure the temperatures are low enough to touch the sample. And disconnect the thermocouples number 3, 4, and 5 from the control panel. Open 2 latches that are tightly connecting the front piece and the end piece to sandwich the middle sample piece. Try to move the front piece and end piece apart a little bit and remove the middle sample piece gently from the cylinder. Now find the new sample piece on the bench. You will insert it into the cylinder's gap. Open the gap between the front piece and the end piece a little bit and insert the new sample piece. Make sure the notches are joined in the right way. Hold the sample piece in place. You should be able to see the thermocouple wires are sticking out upward, and you can read 3 written on the left and 5 written on the right. Now close the 2 latches. Hold the thermocouple cables from the new sample piece. Identify the labels 3, 4, and 5, and insert the thermocouple connector to the control panel 3 to T3, 4 to T4, and 5 to T5. Be aware of the polarity of the connector. The thick metal tip is a minus, and the thin metal tip is a plus. Position the minus tip to the left and the plus tip to the right. Insert the connector number 4 in the same manner. And finally, number 5 in the same manner. Next, go to the back side of the instrument and find 2 power plugs, one for the instrument and the other for the chiller. Plug in the power plugs to the wall outlet. Turn on the switch S1. Turn on the switch S2. Back to the front side of the control panel. You see the temperatures are shown on the display, but the heater is still off and the chiller is still off and disconnected from the instrument. Next, I will show you how to use this recirculating chiller. First, I want you to open this lid and make sure there is enough water inside. The water level should be within 1 inch from the top of the tub. If not, add more water. Then close the lid. Move the water chiller forward a little bit so the water tubes are closer to the water tubes from the instrument sample cylinder. Next, you will disconnect the inlet and outlet water tubes of the chiller. Currently, they are connected to each other, so it's in a self-circulation configuration. Before you turn on the chiller, break the connection. This is a quick connect joint. To disconnect, you pull the female connector's movable portion away from the male connector. If you want to connect, you just need to push the male connector in. Next, you will do the same for the instrument's water tubes. Break the connection of the two water tubes that are currently connected to each other. Then I want you to connect the recirculating chiller's outgoing tube to the instrument's water inlet tube that is connected to the blue tube. You can see the silver duct tapes to match. Likewise, connect the recirculating chiller's return water tube to the instrument's outgoing water tube that is connected to the red tube. Now, all the tubes are connected in a big circle. It's time to start the chiller by pushing this power button. The number shown here is the current temperature, 19.8 degrees Celsius. You want to make sure the set point is 15. To do that, push this circular arrow button. The first number displayed is the set point. It's currently 15 as it should be. If the set point is incorrect, you can change it by pushing the up and then down arrow button. If you push the circular arrow button again, you will see the low temperature limit below which you will hear alarm beeping. It's currently set as 10 degrees Celsius. If you push the circular arrow button once again, you will see the high temperature limit above which you will hear alarm beeping. It's currently set as 50 degrees Celsius. Finally, if you push the circular arrow button once again, you will go back to the current temperature display. When this green ice crystal LED light is on, the chiller is in the cooling mode. This recirculating chiller can actually do both cooling and heating to maintain the desired temperature. But for this experiment, it's receiving heat from the instrument's heated sample, so it should be primarily operating in the chiller mode during the experiment. It's clear the water temperature is going down. It was 19.8. Now it's 19.5, steadily heading to the set temperature of 15 degrees Celsius. It will take a while to reach the set point, and it went down again, now 19.4. You just need to wait. Turn on the heater connected to the front piece of the sample cylinder. Turn on the switch S3 and you will see the power displayed, which is currently 0 watt. You can change the power of the heater by turning the black knob counterclockwise to decrease or clockwise to increase. It's a good time to set up the VDAS data acquisition software according to the other instruction video. After that, run the necessary experimental trials according to the lab manual. When you are done with all trials, turn off the heater. Turn off the chiller. You do the startup procedure backward. First, turn off the power. Disconnect the water tubes. And connect chiller's water tubes to each other. Then connect instrument samples water tubes to each other. And move the water chiller backward a little bit. Turn off the switch S2. Turn off the switch S1. After you turn off everything, chiller and instrument, you can plug off the power cables from the wall outlet. For this additional experiment of gas thermal conductivity, we will use air in the room, which is the easiest example, but you could use another gas as well. You will use these two syringes on the bench. You should never fill liquid in these. First, remove the plunger of one syringe. Make sure the inside is dry and fill it with air. Then connect the plastic tube of the syringe filled with air to the blue quick connector on the gas cylinder. Hold the plastic tube and push it in until it stops. Connect the plastic tube of the other syringe to the blue quick connector on the other side of the gas cylinder. In the same manner, now you will push the plunger of the syringe that is filled with air and confirm that the air goes out of the cylinder from the other side into the second syringe. This means that air went through the cylinder from the inlet to the outlet. Disconnect the second syringe, but leave the plastic tube inserted in the cylinder. Pump air in and out using the first syringe by moving the plunger in and out several times to make sure the cylinder is full of air. Inside of this cylinder actually has a double cylinder structure, and the gas is only in a very small volume of the narrow annular space. Now you will disconnect the plastic tubes of the syringes. To disconnect, push the blue plastic connector on the gas cylinder in and pull out the plastic tube. Do the same for the other side. To swap the two instrument modules, first you need to make sure everything is off. Next, you will disconnect all thermocouple cables from the control panel. Then disconnect the heater power cable by holding the plug piece close to you and turning the other plug piece close to the panel counterclockwise. You can pull it out when the plug becomes loose. Then remove the 4 screws that fix the module's white base to the instrument's gray metal frame. Now you can lift the entire module like this and move it to a side on the bench. Then it's time to bring in the gas thermal conductivity module. Set it gently on the gray metal frame of the instrument. Move it to the right place without pinching any of the wires and tubes. Make sure the base screw holes are aligned and use 4 screws to fix the new module's base to the gray metal frame of the instrument. Connect heater's power cable to the control panel. There is a notch in the plug that should be aligned with the corresponding notch in the receptacle. Push it in, hold the plug piece close to you, and turn the other plug piece close to the panel clockwise. You will connect 2 thermocouples from the module to the control panel. One near the red water tube is labeled 1, and this one goes to the slot T1. The other one near the blue water tube is labeled 2, and this one goes to the slot T2. And you are done with swapping the two modules.